Second method is simple moving average. Simple moving average is actually is a one just moving average of a particular number of accounts. In this method, the mean is only specified as a number of consecutive data which are the most recent values in the series. So the mean of the past values is the new predicted value, forecasted value. Suppose if you have 10 observations, forecast for t plus 1 equal to, if you have n observations, I equal to 1 to n d t equal to 1 to n dt. So forecast of t plus 1 or n plus 1 you will get in simple moving average. But this actually is not practically, nobody uses the simple moving average because the data whatever you have is have randomness, lot of randomness. To capture randomness, you need to consider, because simple moving average, it gives weightage, equal weightage to all values. Suppose if you have data of, like for example, sales data, sales values are 20, 25, 23, 26, 29, 28. So these are the values of 6 months. And if you want to predict for the next month, so if you take entire average, you will get some value which gives a weightage equally to all values. So the drawback of simple moving average is that generally the data behaves near to the behave to similar to the recent values. So but a simple moving average gives weightage, equal weightage to all values. So in simple moving average, equal sorry, weightage is given to all values. But the forecasted value will have more error due to equal weightage to all values. The actual values are impacted by the more recent value. More recent value has more impact than the past values. In general, recent values have more impact than past values. That's why we go for weighted moving average, where the weighted number is given to the recent values. So next method is weighted moving average. In more weightage is given to the new data, recent data, compared to the here more weightage is given to recent data. So forecast of n plus 1 term is equal to sigma I equal to 1 to n wi di, where wi is the relative weight of data for ith period, weight of data for ith period, and sigma of wi I equal to 1 to n equal to 1. Total weight is equal to the 1. So more weight is given to the recent values, and forecast is nearer to the actual value. Whenever you give more weightage to the recent value, then your forecast will be good. So D is a demand and F is the forecasted value. Actual demand F equal to forecast for so if you have data of n periods, n values or n terms, then if you want to forecast for n plus 1th term, then this is the formula for that. So we'll do one simple example which understands period, demand, weight. So 1, 2, 3. We have demands of 105, 108, 1112. Weightage we have given as for recent value, third period has highest weightage. Generally you will have more values, but here we have taken simple example to understand the concept. So what is the forecast for the fourth period? Forecast for fourth period. So weighted moving average, the weighted moving average forecast for the fourth period weighted moving average forecast for fourth period F4 equal to, so as our formula substitute the values W1 D1 plus W2 D2 plus W3 D3. So F4 equal to W1 is 0.1, demand 1 is 105, plus W2 is 0.3, demand 2 is 108, W4 is 0. W3 is 0.6, demand is 112. So the value will get F4 equal to 110.1. So in case of simple moving average, if you use this simple moving average where it gives equal weights to all values, F4 equal to 108 plus 112 divided by 3. We are giving equal weightage 111 to all the one. Here also you can divide by 1. So anything we divide by the same. That's why it is 108.3. In case that weightage is 0.6, 0.3, 0.1 to the above problem, if you change the weights, like decrease less weights to the recent and more weights to the old values, the value will change. Okay, so that's why we need to give more weight to recent values is the data whatever will behave the similar way as the recent values, not as the very old values. Sometimes the data will weightage will be given as in terms of 10, 30 or 1, 2, 3. So sometimes weights are given instead of fraction values, it will be given as more than one values. At that time, the sum of the weights, if it is more than one, if it is less than one, sorry, if it is equal to, it has to be equal to one. If it is more than one means, then you need to think of another formula, like suppose for example in the same one, n plus 1 equal to sigma I equal to 1 to n wi di divided by sigma I equal to 1 to n wi. Even in the above formula also, if you apply this in the above formula, sigma wi equal to 1, so that's why denominator is 1. That's we have taken sum of the all the weights is equal to 1, so the 4 forecast 4 equal to the w1 d1 plus w2 d2 w plus w3 d3 divided by 1. So we do one problem based on that, giving weights other than fraction values, which gives clear picture of the weighted moving average. Suppose demand for John, Feb, oh sorry, demand for John, Feb, March. Demand values and weight values 100, 90, 80. The weight is 1, 2, 3. So for F4 forecasted value, you need to forecast the value for April. So F4 is nothing but forecast of April equal to demand 100 into 1 plus 90 into 2 plus 80 into 3 divided by 1 plus 2 plus 3. So you need to sum the all weights. Equal to 100 plus 180 plus 240 divided by 6. So overall you will get 520 by 6. 86 point fraction value will get 6. So that's why weight recent values we give more weight, because if you look at the data, so it's coming down, so the forecasted value also has to come down. So next is, there is another type of moving average method, like 3 period moving, 4 period moving average also. That is actually n period moving average, which is also called. N is a period. Suppose if you have 10 data points, for example, data points for John, demand values for John, Feb, March, April, May, June, July. So you have demand points like this, 8 months. So if you want to forecast for the ninth month, we have values of 10, 11, 12, 11, 12, 13, 12, 14. So you need to forecast for September. So for that, you can go average method, simple moving average considering all data points. The n period moving average is like, suppose if I want to consider only last 3 months. So 3 month moving average, 3 period moving average is average is equal to, so take the last 3 months June July values. So June plus July plus August by 3, moving average of those all June July values. Simple, I mean moving average. Whatever the period he mentions, we have to take that number of values of recent values. That is n period moving average. Here again you can make it as n period weighted moving n period weighted moving average also. So there again, you have to give weights accordingly. The recent values will get higher weights, and old values will have lower weights. So next one is exponential smoothing. So exponential smoothing, when the data has trend and seasonality, we go for exponential smoothing. So here the values in exponential smoothing method, the forecasting or the weight of the data diminishes exponentially as the data becomes older. So that instead of random numbers we are giving, in integer values or numbers, here exponentially the weights will go down as the data becomes older. Why do we need to this method is, so we can take more number of data points, even though suppose if we in the earlier problem we have taken only 3 months moving average. So instead of that we can take from Jan to August, but the thing is that the weights will less for January, exponentially less. The weightage for every previous data decreases by exponentially. The alpha is an exponential smoothing constant which we discussed. So forecast for the T month is equal to alpha of demand of T minus 1 plus alpha into 1 minus alpha to demand of another whole month, like that alpha into 1 minus alpha square demand d t minus 3 and so on. So d is a demand of particular period, and actual demand, and alpha is a smoothing constant. So regarding the smaller the value of alpha, more is the smoothing effect in forecast. Smaller the alpha value, more smoothing effect. Higher the value of alpha, more robust forecast and response more quickly to the changes. So higher value of alpha means you are giving more weightage to recent values, and higher value of alpha gives more weightage to the recent values. In this, considering simple exponential smoothing, so I mean removing higher terms of alpha, simple exponential smoothing. So here we won't consider the alpha square and all higher degree. Only one degree of alpha is considered. So that's why it is called simple exponential smoothing. Forecast of present month or forecast of next month is equal to the forecast of past month plus alpha into demand minus forecast of last month. So this is a forecast. F is a forecast and D is for demand. T is a time period. T is a suppose T is a present month means T minus 1 is the past last month. Alpha is smoothing coefficient or smoothing constant. So alpha is equal to 2 by n plus 1. So where n is equal to the number of periods, number of time periods. So we do few examples and we'll get questions on exponential smoothing. So n equal to 2 alpha a, what will happen? Substitute n equal to and alpha equal to the value you will get. So higher value of alpha, what it means? Higher value of alpha means implies what? Forecast is implies that the forecast is sensitive to near values. Forecast is sensitive but not stable. So if you are giving higher values of alpha, that means you are giving more weightage to the recent values, which is more sensitive to the recent values. So but not stable. Which signifies current demand is being emphasized compared to historic demand. Similarly, lower value of alpha signifies higher stability, signifies higher stability but low sensitivity, opposite to that. So here we are giving weightage to historic demand also along with current demand. So forecast error calculation. So how do we know that the current forecast is perfect? So I mean the error is less, the forecast is better. Forecast error E equal to demand minus forecast. Demand of the ith period corresponding to the forecast difference. To calculate the difference, that is the error. There are different types of errors which we need to error matrices. One is mean absolute mean forecast error. Mean forecast error. So MFE is equal to sigma I equal to 1 to n demand minus forecast divided by n. So average of all errors. So mean forecast error. So if this error is positive, then it means underestimated, and if it is negative, then it is forecast value is more overestimated. So you know, even though if there is error also, mean forecast error may come zero because of we are taking actual values. So suppose there are 10 observations, 5 observations came as positive, 5 come negative. After summing of negative and positive, if you get zero, so as per the value, it is telling that there is no error. But if you look at the data for each observation, there is so much error. So that's why it deviates. It won't give exact values. It deviates from it deviates by considering positive and negative errors. So to avoid this, there is another method is mean absolute deviation, MAD. This is considered as a best method for forecast error quantification. So MAD equal to sigma I equal to 1 to n di minus forecast divided by n. So this is best method for calculating forecast error. So it takes absolute values of the each value observation error, error in each observation. So it sums up the absolute values. Next, another method is mean square error. So MSC, sigma I equal to 1 to n demand minus forecast whole square by n. Squaring the errors of actual values, because demand minus forecast, as we have discussed that in mean forecast error the errors may be positive or negative. So to avoid that nullification of positive or negative cancellation, we have squared the errors such that you will get the positive value. Mean absolute percentage error. MAPE, it is also called demand minus forecast divided by demand to n to 100. So for each observation we have to calculate the forecast error, mean of percentage forecast error, mean absolute percentage. Whatever he asks in exam, you need to calculate. So there are other errors also, but out of this, these are the important. And mean square error we have discussed. Mean absolute is important one, and there is another error like bias. How much is a bias means deviation. Bias is also a measure of the average of squares of all observers in the forecast, and in turn a positive bias indicates the underestimation while as negative bias indicates the overestimation. So bias equal to sigma I equal to 1 to n demand minus forecast by n. So here it is positive bias indicates underestimation, and negative bias indicates overestimation. So that's about errors calculation. And if you look at the gate questions, few gate questions which they asked regarding the forecasting, mostly they asked in exponential smoothing. So gate 2010, question number 1, gate 2010, 2 marks question. The demand and forecast for February are respectively. So demand month is February, and demand and forecast for the month of February is 12,000 is demand, forecast is 10275. Using single exponential smoothing method, smoothing coefficient alpha equal to 0.25, forecast for the month of March. So he is asking what is the forecasted value. So solution is how we need to go is, first of all, single exponential smoothing. by using single exponential smoothing. So forecast of March equal to forecast of February plus alpha into demand of February minus forecast of February. So here alpha how much he has given 0.25. Substitute that value. Forecast of February is 10275 plus alpha is 0.25 minus 12,000 minus 10275. So you will get that one as now the forecast minus demand is negative. So value your answer is so answer if you simplify this forecast for March equal to 10706.5. So that is the answer. So options he has given is A 431, B 9587, C 10706, D 11,000. So even if it by looking at the options we can eliminate first option which is unusual, and out of the three which are near to the 10,000, so you need to check. So we got 10. C is the answer. So next question number 3. Which of the following forecast methods takes a fraction of forecast error into the account for the next period forecast? So here he has given simple moving average method, and weighted moving average and exponential smoothing method. So out of this, see simple moving average, it it won't take the error of the whole past term. So in weighted moving average also same. All these moving averages it won't consider. But in exponential smoothing, it's each term, like demand is equal to the forecast plus forecast is equal to the alpha of demand plus alpha of into 1 minus alpha of demand minus 2, like it multiplies, goes on multiplying in the old values. So that's why it depends upon the past error also compared to other thing. So in the next question is question number 4. GATE 2008 2 marks question. A moving average system is used for forecasting weekly demand. FT, F1T and F2T are the sequence of forecast with parameter M1 and M2 respectively, where M1 and M2 denotes the numbers of weeks over which the moving averages are taken. The actual demand shows a step increase from D1 to D2 at a certain time subsequently. So he has given moving average system weekly demand F1T and F2T forecast with parameters, means the moving average 6-month moving average. So M1 is equal to M1 and M2, given M1 greater than M2. So m1 is, suppose for example, m1 is 3 and then m2 is 2, like that. 3 period and 2 period moving average is taken. So actual demand shows a step increase from the D1 to D2 at a certain time. So actual demand shows increase in the demand shows a step increase. Subsequently, options are neither F1 nor F2 will catch up with the value D2. Second option is both F1 and F2 will reach D2 at the same period. And third option is F1 will attain the value D2 before F2. Fourth option is F2 will attain value D2 before F1. Since if you look at the options, weightage of the latest demand would be more in F2, right? So hence it would attain the actual value earlier because M1 is greater than M2. So that means if you suppose for example, if I am taking M1 as 3 and M2 as 2, so more weightage is given to the recent in F2. So that's why the answer for this is D. F2 will attain the value of D2 before F1. Another logical question which they are connected to concepts like weighted moving average and exponential smoothing. So the question is question number 7. GATE 2005. So the sales of a product, he has given the sales of a product during the last 4 years. Sales during last 4 years. So actual sales, one sales of 1, 2, 3, 4 years. Forecast value is, so sales for first year is 860, second year is 880, third year is 870, fourth year is 890. And the forecast for the fourth year is 876. The forecast for the fifth year using simple exponential forecast for fifth year simple exponential is F4 plus alpha into D4 minus F4. Okay, using simple exponential smoothing, forecast for fifth year is equal to the forecast using 3 period moving average. Forecast for fifth year using 3 period moving average. So 3 period moving average is F5 equal to average of last F4 plus F3 plus F2 divided by 3. 3 period moving average, last 3 periods. So equate these two, equation 1, equation 2. 1 equal to 2. Equating both equations, F4 plus alpha D4 minus F4 equal to f2 plus f3 plus f4 by 3. Sorry, not f4, sales. This one is D, demand or sales or demand. D. Just please correct it. So F4 is nothing but 876 plus alpha D4 is 890 minus F4 is 876 equal to D2 is 880 plus 870 plus 890 divided by 3. So 876 plus alpha 90 minus 76 14 equal to 880. So 14 alpha equal to 880 minus 876, that is equal to how much? 76 minus 4. So alpha equal to 2 by 7. Answer is C. So if you know the weighted moving average, then only you can solve. Even though if you know simple exponential smoothing, you can't solve this.